Folks, I'm going to get right to it today because now we're going to be going into IQR, Interquartile range. Now, the name itself sounds way fancier, but if you can make sense of the name, you can actually do this fairly simply. It will take some work and some practice. It's new, but once you get the hang of it, it's not that bad. The first thing I'm going to do to try to explain interquartile range is I'm first going to focus on one word in particular, and that is quartile. So quartile is just a fancy way of saying take your data, your whole data set, and divide it into 4 parts. Quartile, fourths. So we're going to take our data set and divide it into fourths. And I'm going to show you how to divide a set of data into fourths. And for those of you who like steps, like I like breaking things into steps, I'm going to do that now, and I'm going to use this example. Maybe you want to take notes on this or write it down, or maybe pause it and screenshot it once it's done, and you could use that as notes. But here we go. Step 1. If you want to break a data set into fourths, the first thing, and I'm actually going to put a pre-step. I'm going to put it in smaller font. Pre-step. Put data in order from least to greatest. So your first step before anything else is you've got to order your data from least to greatest. You can't do anything unless that occurs. Then your actual first step is find the median, which we learned yesterday is the middle number of the data set. So we're going to cut our data in half. All right. In this data set, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers. So to cut that in half, I'm going to go from back to front. I'm just going to wait till I find the middle. And in this case, the middle is 28 and 30. So I hope you remember what to do. If you have 2 middle numbers, the way to find the actual middle is to add them up and divide by 2. And when you do that, the true middle of this data set is in between 28 and 30. It's 29. And then we have a lower set of data and an upper set of data, all centered around our median. So a lower and an upper half. And the second step that we're going to take is we are going to find the median of the lower half of the data. All right, so that means I'm going to be focusing in on 18 to 28, the lower half of the data, and we're going to find the middle of that. So the middle of this is 22. So there is the middle of the bottom, 18 and 21, 24, 28. There's 5 numbers, so the middle is the third number. And then my last step for cutting a data into quartiles is, similar to step 2, we are going to find the median of the upper half of the data. So we're going to find the middle of this upper half. And to do that, there's 5 numbers, so the third number is the middle of that. Woof! All right, so what we've done now is we've broken this into quartiles. You might not be able to see it, but I'm going to show you where these are. All right, so here's quartile 1. Quartile 2 ranges from there to here. Quartile 3. All right, so I've got 1, 2, 3, 4. I have 4 quartiles, 4 sections of data. This is how data scientists have determined that you can cut a data set into 4 parts. And the steps I've broken out for you: find the middle number, then find the middle of the lower half, and then find the middle of the upper half. Sounds a little kooky, but that's how you do it. You find the middle of the bottom, the middle of the upper. And I'd just like to point out one thing we're going to come back to later in this lesson. 22 was the middle of the bottom half. That has a special name. It gets called Q1. And 32 was the middle of the upper half. That has a special name. It gets called Q3. Not important this second, but we'll come back to that later. Q1 and Q3. Anyways, how do you break a set of data into quartiles, into fourths? Simple, you follow these steps. And because that's a kind of a crazy process and it's new to you, I'm going to do it once more with a different set of data. We're going to follow these same steps, step 1, 2, and 3, but we're going to use a new set of data. It's actually a play on the example from before, but I've slightly tweaked the numbers. This is me being brought on by the Mavericks. This time, it's in my last 11 games, and that means there's 11 point totals here. I had a real stinker. I only scored 2 points. I had that big, awesome game where I scored 50 points, and then there's a lot of stuff in between. And we're going to break this into quartiles. So step 1. Pre-step, put the data in order from least to greatest. Did it for you. Step 1, find the middle number. So the middle number of this data set, if we count into the middle, is this 15 right here. That's my median of the entire data set. Now I have an upper and a lower half of data, and we're going to, as our last 2 steps, we're going to find the middle of this, and we're going to find the middle of this. So my median, my actual middle number, that cuts the data set in half is 15. And then I'm going to find the middle of this and the middle of this. So the middle of the lower half is 12, and the middle of the upper half is 18. How'd I find that? There's 5 numbers in the lower half, and there's 5 numbers in the upper half. 12 is in the middle of those 5, and 18 is in the middle of those 5. And there we go. We've broken it into fourths. This is the first section, this is the second section, this is the third section, and this is the fourth section. And like I had mentioned before, 2 of those numbers in the entire data set have fancy names. This is called Q1, and this is called Q3. All right, we've actually not even done IQR yet, but we're really close. So don't feel like, oh, there's so much more. It's not too much. We're really close. What we've done, just to recap, is we've taken a set of data and we've learned how to cut it into quartiles, into 4 sections, following these steps that you can see on your screen. Now, we're going to take that and we're going to make it awesome. We're going to find the actual interquartile range. I like this lesson. So, what the heck does interquartile range even mean? Let's break down those words. Inter means the middle, like in between, inter. And quartile, we just learned, means breaking something into fourths. Quart, 4, fourths. So interquartile means the middle of the fourths. And interquartile range, if you were going to put it in simple words, all it means is you're going to find the range, which you learned how to do before. Range is just subtracting the bigger from the smaller, or excuse me, the smaller from the bigger. And we're going to find the range of the middle part of the data. So let's go back to the example we just did before. Literally just did this. We found that the middle, step 1 is 29. The middle of the lower half, which we're going to call Q1, is 22, and the middle of the upper half is Q3. So we've done actually 90% of the work. Now we want to find the interquartile range. There's just one more step. It's a pretty simple step. Find the range between Q1 and Q3, aka all we're going to do is we're going to subtract Q3 minus Q1. 1. So 32 minus 22 equals 10. All right, so I feel like the steps that we did, although they're new to you, they aren't that complex, right? We found the middle of the data set. We found the middle of the lower half. We found the middle of the upper half. And then we found the range. Now, why would you even do this? Well, here's why. This data set, its actual real range, ranges from 18 all the way up to 37. It's a pretty big range. So data scientists wanted to create a way where you could find a range that focuses a little bit more on the middle part of the data. And why would you want to focus on the middle? Well, what is sometimes on the outsides of a data set? Outliers, right? Outliers are numbers that are sometimes really big as compared to the rest of the data set, or really small as compared to the rest of the data set. So they wanted to find a way to find a range, a measure that tells us how spread out the data is, that kind of eliminates any outliers. So to do that, they figured, let's break the data into fourths, and let's ignore the bottom half and ignore that upper half. Let's really just focus on the middle here, because the middle is where most of the numbers in theory are located. Not a lot of stuff is on the upper part, not a lot of stuff is on the outer part. Most of the stuff's in the middle. So let's focus on the middle. And so they found a range, interquartile range, the middle quartiles. And that tells us that most of this data is spread between 22 and 32 and has a range of 10. That's a much tighter range as compared to the actual range, which would be 37 minus 18. And to make that a little more, hopefully at least a little more real to you, I'm going to redo the basketball example that was on the previous slide and finish it. We're going to find the actual IQR. So to find the IQR, do exactly what we did before. The middle of the data was this 15, and that gave us a lower half of data and an upper half of data. And then we're going to cut those halves in half. So 18 was the midpoint of the upper half, and 12 was the midpoint of the lower half of data. So this is called Q1, and this is called Q3. And our fourth and final step for finding the actual IQR, is you simply find the range of Q1 to Q3. So that middle range is 6. And then, just to help you see this a little bit better, what's the actual range, the real range? Well, in reality, I scored 2 points in one game and 50 in another game. So if someone just said, "Oh, what's his range? Like, what's his spread of his data?" I can score anywhere from 2 to 50, man. I can score within a range of 48 points. That's massive. But that's also not typical. It's not typical that I score 2 points. Everyone has a bad night here and there, even LeBron. And it's not typical that I score 50. I'm not a mega superstar. I'm not a LeBron or a James Harden. I'm not scoring 50 points a game as a typical thing. It happened. I got hot one night, but that's not normal. So the IQR helps us to focus and find a range on what's normal. Normally, I'm scoring somewhere between 18 and 12. And the interquartile range focuses in on these normal scores for me. Most of the time, I'm somewhere in here. So most of the time, I score within 6 points of myself. Somewhere from 12 to 18. I have a range of 6 points. So hopefully that somewhat helps you tell what IQR and why it's helpful. It helps you to focus on the middle part of the data, which most people feel like that's where most often things are going to happen, and it eliminates the outliers from your range. All in all, range and IQR help us know how spread out our data is. And I'm going to do one more thing. Zero math, more just thinking. This last slide is a thinker slide. Miss Moore and Miss Hitchin came up with this example, and I thought it was a good one. And it's in your written notes, but I wanted to include it in the video for today. So it says a group of students take a math test that's out of 100 points. And they also take a social studies test that's out of 100 points. So two separate tests, two separate sets of data, and then they went and pretended that they found the IQR. So they took all of the students who took the test, they ordered them from least to greatest, they found the data's quartiles, and then they found the IQR. So what does the IQR tell you? Well, in this example, let's start with the math test. The math test has an interquartile range of 25. What that means is that the middle part of the data is spread out by 25 points. That means maybe in the middle of the data, the upper part of the data is like a 90, but that would mean that the lower part of the data is a 65, because the IQR tells us that the middle of the data is spread by 25 points. A high IQR might tell you something's wrong. It depends on the scenario, but in this scenario, it tells us something might be wrong. Why are most people, sure there were some people who scored less and some who scored more, but why are the bulk of people in these middle quartiles have such a high range? That's concerning, possibly. Now, let's take the social studies test on the other hand. Maybe the upper number quartile was 87, but the lower one was only an 82. There was only a spread of 5 points. It's much closer together. There's a smaller gap. So that tells us we can assume that most of the people taking this test had a pretty similar grasp of the material. They all were in a similar range. They all had a similar understanding. Their grades weren't that far off. Whereas on the math test, people were all over the place. Some people had no idea, bombing it. Some people had a really good grasp. They were getting a 90. Anyways, that's just paints a little bit of a picture of what IQR can tell you. It can give you a little glimpse as to what's going on depending on the scenario. All right, I'm going to stop talking. Hopefully this helps you with your work today. You've got some practice problems to do. Reference this as needed. Ask us questions as needed. It's not the easiest of things, so take your time, do your best, and happy math!